All right, this is section 12.2. So we are doing more on domain and range, graphing different kinds of functions and identifying their domain and range. So first thing we're going to do is, yesterday we talked about, on 12.1 we talked about domain and range and what it looks like in the table and what is a function and what it looks like in the table and in the map. Today we're looking at our domains and range on the graphs. Okay, remember our domain is the set of inputs, the range is our set of outputs. What's the depender in that relationship, the x or the y? Yeah. The y is, or the range is always depends on what we're inputting, right? Remember, a function's a rule that describes a dependent relationship between the two. So now we're going to start getting into some word problems. Two quantities. For exactly every member of the domain, there's exactly one member of the range. No repeated x's. Okay, do you guys remember the vertical line test? Yes. So we can tell in a graph if it's a function, because we can take that same table, graph it, and if it passes the vertical line test, that's another way. So they might just give us the graph or they might give us the table. In the table, we look for repeated x's. In the graph, we look for, does it pass the vertical line test? So when I look at the first graph, you can see as I run a vertical line, at no point in time does it cross my red line at two times in the same moment in time. If it doesn't cross it at 2 times in the same moment of time, it is a function. So yes, this is a function. Let's look at number 2. Does it pass the vertical line test? Yes. Yes, because it doesn't cross this red line at 2 times in the same moment in time. Only at one given point in any moment in time. Okay, whereas this, if I use my vertical line test, does it cross 2 points on the line? Yes. Infinite points, right? You can see it goes really fast. I don't know why it's so fast. I got to fix that timing.
Because there's no line.
Okay. So do you understand what I'm saying? So this is not a function. So basically, vertical lines are not functions. The next one, parabolas. Are they a function? Yes. Yes. They're, anything that's a slant is a function. If it's a vertical line, it's not. There's a slight slope to this line here, a slight slant. So that is, in fact, you can see it only passes any given point at one point. All right, the next one. Okay, it's not a function because right here it's clear we can see it passes at 2 points in the same moment in time. Is this a function? Yes, this is x cubed, by the way. Is this a function? No. Okay, not a function. By the way, this is, and we'll see this later, it is, well,
absolute value, right?
No, it's absolute value, yes, of y. So x equals the absolute value of y. Okay, and then the next one. Not a function. So everybody's remembering the vertical line test? Okay, number 1, is it a function? Yes. Let's go thumbs up, thumbs down. Keep them low so people can't copy you. Okay. Okay, number 1 is a function. Number 2. Vertical line test, does it pass?
I'm looking at 3.
Yes, it does. It's a function.
Yeah.
Okay, number 3. Okay, number 3. Is it a function? You're correct. It is not a function, does not pass the vertical line test. Number 4, Lucas Malou. Is it a function?
It is not.
Because?
Because 5 goes into 2 outputs.
Right. So because 5 repeats, I have 5, -1, and 5, -2. Questions? Okay. And then 6 goes with 3, so that is not a function down there either. Okay? All right, now we're stating the domain. Stating the domain. Okay, we have two rules. We have rules for fractions. We have rules for radicals. The rule for a fraction is what? Yep.
Can't be 0.
Can't divide by a 0. Can't have 0 in a denominator. Rule for radicals is what? Yep.
You can't have a radical in the denominator.
Yeah, but that's not really the rule for what x is allowed to be in a radical. That's true, but Oliver?
It can't be negative.
It can't be negative, so it has to be greater than or equal to 0. So number 1, what is the rule? What is the rule? It's asking domain, so what is x allowed to be? Ansana?
X is greater than or equal to 0.
And x is, what else is it allowed to be?
Elements of the reals.
Element of the reals, that's right. Okay, number 2. Gavin.
X is an element of the reals and X cannot be less than
We don't say cannot be.
and
X is.
greater than or equal to 0.
Good. X is greater than or equal to 0. Remember we take the 7x? Always set it greater than or equal to 0. Okay? Next one. Sarkis.
X is the element of the reals. X cannot equal 0.
No, close. What will give me a 0, Sarkis?
X
What will give me a 0 in the denominator?
or 4.
It's not 0 or 4, it's only 4. 0 will not give me a 0 in the denominator. Do you understand that? That is big clarification. I think you made that mistake before. It's not 0, it's what makes it a 0. So it's only the 4. X has to be greater than or cannot equal 4. Sorry. Number 4. Number 4. How about Caleb?
X is an element of the reals and X is greater than or equal to negative 3.
Perfect. Okay, questions? Okay, let's look at some others. Y equals the absolute value of x. How about Ellie? Sorry, not Ellie, Leah. You do look so much like Ellie to me. You both have the glasses. That's it, really. Shh. Go.
X is the element of the reals. And X cannot equal 0.
No, it can equal 0. I can take the square root of 0. What's the rule for a radical? You guys keep forgetting. Berenson.
X is greater than or equal to 0.
Greater than or equal to 0. When it's can't equal is when it's in the denominator, as in, does that make sense, Leah? Okay, x is greater than or equal to 0. Number 6, Michael.
X is an element of the reals, and X cannot be. Cannot be.
X is. Don't tell me what it can't be.
Greater than or equal to 0.
Good. No, not 0. You have to set what's inside
Negative 5.
-5, right, not 0. You have to set the inside of the radical greater than or equal to 0. Michelle, number 2. Number 7.
X is an element of the reals, and X is.
That's it. Just x is an element of the reals. It's any real number. Right? Next one. Leah.
X is the element of the reals, and X is greater than or equal to 3.
Yes. Are you understanding that, Sarkis? Okay. Okay. Double trouble. Double trouble. Lucas W. Instead of me saying his last name, maybe I should just... It's not wine. Go. Shh. Shh.
X is an element of the reals, and X is greater than or equal to 0.
That's for the radical, but it's also in a denominator. No, so it's not greater than or equal to 0. It can't be 0.
Yeah.
Right? So how would we say it?
X is greater than 0.
Greater than 0. Perfect. Wow, how slight is that? Right? If I had said greater than or equal to, one little line right here would have made that wrong. So do you understand the difference? Because I had to satisfy 2 rules. Okay, number 10. 10, how about Una? Not Luna, but Una.
X is an element of reals,
And
and X is
when do I use greater than or less than?
for radicals.
And when do I say cannot equal? Fractions. What would give me something in the denominator that's not allowed?
4.
4. X cannot equal 4. So the domain big rule is it cannot equal 4. We really should be writing it's an element of the reals and blah, blah, blah. I guess they're not writing it there because they're assuming you can do imaginaries. What would 11 be? So it doesn't, you know what? Do you understand why we're not writing reals for number 9?
Yeah.
Because they're doing imaginaries. You can do the square root. Well, maybe not. No, that's not assuming.
You would do the square root of imaginary, so it would produce the imaginary result.
Yeah, it's not imaginaries. It's just, it's a, it would still be. We can still do that. Okay. I don't know why they didn't write that. Okay, number 11. Let's go with Lucas Malou. The domain.
X is an element of reals.
And
And X not
9, because that would give me a 0. And also
2.
the radical rule. What must it be greater than? Or equal to? No. Who knows? Oliver?
0.
Right. It has to be greater than or equal to 0. Can't be a negative in that radical. And it can't equal 9. And it's an element of the reals. Okay, number 12. Number 12, Daniel Bang. What would give me a 0 here? It's a fraction, right? What gives me a 0 here? 3. And what gives me a 0 here? Negative 5 over 2. Right? Okay. So you've got 2. You understanding? Okay, now graphing. What shape should this make? What shape does this make? It makes a V. Now, the difference is, I told you, we're going to drop, it's going to end up dropping down. If I put it into a table, the absolute value of 3 is 3. Negative 3 is 3 minus 2 is 1. Okay? The absolute value of negative 2 is? 2 minus 2 is? 0. The absolute value of negative 1 is?
1.
Okay? The absolute value of 0 is? Minus 2. So what happens when we have absolute value and outside of it a minus 2?
So vertex shifts down.
It shifts down because it becomes the y-intercept. That's where it crosses. Is that making sense? Shh. Okay, next. Okay, it is a oh yeah, so is this a function? Yes, it passes the vertical line test. And then it says state the domain and range. The domain, what's x allowed to be? If it goes on and on. All real numbers. Okay, what about the range? It's an element of, and would I say x for the range?
Yes.
No, we say y. Yes?
Y is greater than or equal to -2.
How? Okay, so when we're asking for the range here, Lucas, we're looking at, when we're asked for the domain, I'm asking how wide is this allowed to go? Since it's a pattern with no specific inputs, it goes on and on forever widthwise. So my domain is an element of the reals. Every real number is a possibility. But my range, it will go on and on from this point higher. So what did you say?
Greater than or equal to -2.
Greater than or equal to -2. Y is greater than or equal to -2. Yes, I'm understanding. No, I'm not. I need to see your thumbs.
Oh.
Not under the table where I can't see. Okay, so when we're asking for domain, we really know that since this has an arrow, it's going to keep going on and on and on. So eventually it's going to use all of these x's, right? That's why we say it's x is such that x is an element of the reals, because it's going to use every real number. But the height, Una, which is the range. Range is height. It's the y. It's never going to be, notice here is -2. There's no points. It'll keep going higher and higher and keep using all of these points, right? But it's never using anything down here. Nothing less than the -2. Are you guys with me? So that's like the boundary line. Y is greater than or equal to -2. A lot of this is what we were doing in Desmos. Does that make sense? Luna, is that clearer now? Una, sorry. I always correct myself by saying Luna and then I go back to it. All right. What shape is this going to make? Show me with your fingers. Draw it. It says x squared. I see 1, I see 2, I see 3. Okay. It's a parabola. Anything x squared will make a parabola. So if I get to choose my x's. -3 squared is what?
9.
9 minus 5 is 4. -2 squared is?
4.
Minus 5 is?
1.
-1. -1 squared is? Minus 5 is? 0 squared is? Okay? Go. If we finish graphing this up, okay, now what I want you to notice is, notice that when I have 4, I have 4 and a 4, right? Boom and boom. These are equidistant away. This is a line of symmetry. The y-axis is a line of symmetry. Notice this are both 2 units away, right? So when x is -2, really, okay, we're getting the same y values, okay? You understanding the symmetry there?
Yeah.
So with parabolas, we will always have those. That's where we're moving next. We're going to be graphing. It's a long, involved lesson. That's why if we can save time here, I can gain an extra day for you with graphing. So let's say you only have this point, and this point. You really have 6 points. You know you'll have this and this. Does that make sense?
5.
If you have 3 points, you really end up with, yeah, you're right, 5 points. All right, so my domain here. Domain. Is it going to go on and on forever? Is the width going to go on and on forever because it's slanted? So that would be all real numbers. This time, Una, what's my range going to be? Y is such that?
Y is such that.
Okay, go on. What did you say? Y is such that? How high can it go? What's the boundary? -5. Notice we would say y is such that y is greater than or equal to -5 and an element of the reals. But you will also notice it's right here. Right? There's your, yeah.
This is why you can find the range of a quadratic by completing the square.
That's a whole nother lesson. We're not doing that now. Okay. Next graph. So the h of x equals 2 to the x power. State the domain and range. Okay. So my question to you. Okay, let's look at this. Remember, this time, where am I putting the negative 2? Where? Where do we put the negative 2? In the exponent. The input goes into the exponent. What kind of function do you think this is called? Come on, guys. If it's going into, you put your hand down. If it's going into the exponent, what do you think it is? It is exponential. Now, these are amazing functions, especially when money is involved. Okay? So let's look. Negative 2 squared. Really, that implies it's a fraction, not a negative number. Remember, 2 to the negative 2 power is like doing 2 to the negative 2 is 1 over 2 squared. What does that equal? 1 over 4, which is what decimal? 0.25, right? Okay. 2 to the negative 1 power, what would that be? 2 to the negative 1. Isn't that 1 over 2 to the 1? Isn't that a half? So it's 1/2 or 0.5. 2 to the 0 power, what does that equal? What does it equal?
1.
It equals 1. To anything to the 0 power equals 1. 2 to the first power. 2. 2 to the, what does it look like? It's increasing so small right here, right? It's barely moving. Okay, 2 to the second.
4.
Okay, it's starting to get up there. 2 to the third. 8. 2 to the fourth.
16.
2 to the fifth. Oh, okay, now it's finally increasing. It's getting up there. Okay, so my question to you is, well, first of all, okay, I'm trying to think of which question I should pose first to you, is why I'm hesitating. I want to know, would you rather have $1 million or a penny that doubles every day for a month? Well, I'll accept it, but I need you to show me in a table why. What are you going to make on day 1, day 2, day 3, day 4, day 5? Shh. Yeah, so on day 1 we get a penny. Day 2, what do we get? Day 3?
4 cents.
Day 4?
8 cents.
Day 5?
16.
Okay, I want you to put it in a table and you tell me, justify it.